Hey everyone, just wanted to take a little bit of time here and look at some questions from the study guide here. So we're in week 8 doing water hydraulics. And let's look at some of these questions. So we're in question 24. A tank is 20 feet high. It has a pressure gauge at the bottom and at each quarter of the way up at 5, 10, 15 feet. Pressure gauge at the bottom shows 14 psi. How many feet of water is above the gauge? All right, well, let's think about that. So we got 14 psi. And then if we do our conversions back to heads, when we talk about head, you can think about it as in that tank being 20 feet high, that's 20 feet ahead. So 14 psi, we know when we convert that, we can say, okay, 1 psi equals 2.31 feet. So let's do a little math here. Let's go 14 psi times by 2.31 feet per psi. And that tells us that, whoa, there's 32.34 feet of water above the gauge. So knowing our tank is 20 feet tall, there's probably an answer here, something like the reading's not possible. There, we got it. Next question, very similar. Tank is 20 feet high, pressure gauge at the bottom. Pressure gauge at the bottom shows 4 psi. How many feet of water is above the gauge? All right, let's do the same thing as we did before. 4 psi, let's put that into feet. And we're going to do that because we know that it's 2.31 feet per psi. So 2.31 feet per psi times 4 psi tells us there's 9.25 feet. Let's see how we did with that one. 9.25, we got it. All right, so I think we're on track with those. Let's keep looking at some others here. Okay, we'll get into question 29. What is the smallest diameter pipe that can be used safely to convey 75 gallons a minute of water? I am going to just write that down. So we're looking to convey 75 gallons per minute. Now when it asks to safely convey, why is it asking about being safe? And that's where it talks about the velocity of the water, where we always want to stay under 5 feet per second in pipes. So I'm going to bring up the same chart just on another tab here so you can see it a little better. So we're looking for 75 gallons a minute. See if we can show this all. So 75. If we come down the side here, we see 75. Now let's go over. These gray ones, usually that's where we're above 5 feet per second. So if we go over here, okay, 4.41 feet per second. So that's safe. What do we got? That falls in the 2.5-inch pipe category. So let's come back to our study guide, and we're gonna see if 2.5 inches is correct, and 2.5 inches is correct. Okay, now let's skip ahead here. Let's do this one. So question 32. Now let's make this trigger. It says now you need to move 3,500 feet to your irrigation main system from the pump. What would the friction loss be for 55 gallons a minute through 2.5-inch pipe? All right, now let me write that down so we keep this all straight. So we're looking for 55 gallons per minute of flow through a 2.5-inch pipe, and we're looking to move that water 3,500 feet. Okay. So if we come back to our chart here, let's we said 2.5-inch pipe and 55 gallons a minute. So let's come down the side here with our gallons per minute, 55, and our 2.5-inch pipe. Where was it? Right there. So we come in at 3.23 feet per second and a psi loss of 0.64 psi. Now, what is that talking about? Is that talking about for the whole length, that 0.64 psi loss in this column? No, so this is what we need to be careful of. So that's talking our psi loss per 100 feet. So that's saying for every 100 feet of pipe, we're going to lose, wherever that was, 0.64 psi of pressure. All right, so let's come back to our question. So we're going to go 3,500 feet. So we know how much PSI we're going to lose for 100 feet. So now what we need to do is figure it out for 3,500. So if we go, first of all, we'll go 3,500 divided by 100. That'll tell us 35 lengths of that 100 foot length. So 35 lengths times 0.64 psi tells us we're going to lose about 22.4 psi is going to be our friction loss. And let's see if we got that one right. Come down here, 22.4 psi. Hey, we're doing all right. Now let's skip a couple more questions. We'll jump here to 35. Okay, now this is basically very similar questions. Okay, 30 gallons a minute, 1,800 feet, inch and a half diameter pipe. So we're getting good at this. We understand this part. How many feet of head is the loss equivalent to? Okay, so now this is looking for a different type of answer. This isn't looking for pressure in PSI. This is looking for feet of head. So let's do like we did with the other question, and we'll go to the other chart. So we got 30 gallons a minute. We're gonna go 1,800 feet, and we're using inch and a half pipe. All right, let's go to our chart where we can see a little better. Inch and a half pipe, 30 gallons a minute. Okay, so our pressure loss we can see is going to be 1.59 psi, and that's per 100 feet. Okay, so let's come back at here and look at this. Okay, 1,800 feet. So we know we got to divide that by 100. So we have 18 lengths, and we're going to times that by, oh, I already forgot our number. 1.59. So 18 by 1.59, that's 28.62, and that's PSI. So now we want to convert that to head. So how many feet of head is that? Well, kind of like we looked at earlier. So we said 1 PSI is equivalent to 2.31, feet of elevation, feet of head. So let's multiply that. Let's go 28.62 times our 2.31. That gives us 66. Now let's see how we did here. Okay, about 66 feet. So there's a little bit of help on the study guide. Hope this is good. Let me know if you have questions, guys. Thanks a lot.